Hey, good morning, class, and welcome to lesson 4.1.3. We'll see how much we get through. This may end up being a lesson that we split into a second video. Lesson 4.1.3, how can I locate the roots? So far in this chapter, you have graphed and written equations of polynomial functions with real roots in factored form. In this lesson, you'll continue to explore the connections among the roots, the equations, and the graphs of the polynomials, even when the roots are not visible on the graph. So our goal today is to be able to take a look at an equation, a polynomial equation, take a look at its graph, find all the roots, and find all of the factors. So let's begin with 435 parts A, D, and G. We want to be able to identify the degree of this polynomial and the number of real roots. In part A, the degree of our polynomial is going to be 4 because there are 4 x-intercepts. And each one of those intercepts represents one real root, so there's going to be 4 real roots. Now this is the minimum degree. It could be larger, and that's something we will discuss as we move through chapter 4. In part D, we have a place on the x-axis where the graph bounces. This ends up being called a double root. And then there's 2 more x-intercepts. So our degree is a double root, which is worth 2, and then the other 2 x-intercepts is 4. But our real roots happens to only be 3 because there's 3 places on the x-axis that the graph crosses or bounces off of. And in this last one, we only have 1 place where it bounces off of the x-axis. So there is a double root at this particular location, and this other local minimum is going to lead to non-real roots. And so this is still going to be of degree 4 because these non-real roots have to occur in pairs. So this is going to account for 2 roots, and this is accounting for 2 roots. So the total is going to be of degree 4. Number of real roots, though, there's only 1 place on the x-axis that the graph bounces or crosses, so there's only 1 real root. Now what we'd like you to do is advance to the next slide. Here, this shows the answers for 35. Sorry about that. If you want, you can go back, review this information. And if you want, but I'd like you to pause this lesson and just take some time to find the degree and the number of real roots for B, E, and H. Find the degree and number of real roots. Once you have found those, please come back and check your solutions. Okay, welcome back. Now this kind of looks like a quadratic, and we know a quadratic could be of degree 2 at minimum. It could be higher, it could be of degree 4, degree 6. But again, that's for a topic later. And so we have 2 x-intercepts, that's going to give us 2 real roots. And in part E, again, it looks somewhat like a quadratic, so the minimum degree is going to be 2. And this happens to be a double root. So our number of real roots is a typo on my part there, is just 1 real root that gets counted twice. And in part H, here the degree is 2, but the number of real roots is 0. This minimum, which is above the x-axis, is going to lead to 2 non-real roots or 2 complex roots. Now go ahead, pause this, and try C, F, and I. Okay, welcome back. And in part C, your degree is 3 because it crosses the x-axis in 3 locations. That also then gives you the 3 real roots. In part F, the degree is still 3. There's only 2 real roots, but that 1 real root is a double real root, so it counts as 2 towards the overall degree, along with the other place where it crosses the x-axis, for a total of degree 3. And in part I, we only have the 1 x-intercept, that's the real root. And then this little area over here is going to lead to 2 non-real or complex roots. So your non-real roots will always come in pairs. You'll see non-real roots of polynomials under these following situations. In a quadratic, if there's a min or a max that is not on the x-axis, in other words, that's either a minimum that's above the x-axis or a maximum that's below the x-axis, or in any polynomial higher than degree 2, there happens to be a local minimum above the x-axis or a local maximum below the x-axis. Our fundamental theorem of algebra. This gets into discussing how many complex roots a polynomial has. Therefore, meaning if you have a polynomial of degree n, it is going to have n complex roots. Now, please remember from your Algebra 2 work that every real number is also a complex number. So we're going to take a look and find all of our real and complex roots in a polynomial. And that's another way to interpret the fundamental theorem of algebra. The fundamental theorem of algebra is really saying if we have a polynomial of degree n, then its combined complex roots and real roots will add up to n number of roots. So in P of x equaling x cubed plus 2x squared plus 2x minus 5, we want to list all of the possible factors that can occur. Now, in order to find the possible factors, you need to use something called the rational roots theorem. And that's on the math notes for this section, and it's at the end of our slide presentation or at the end of the lesson. The rational root theorem says to find possible factors of a polynomial, what I need to do is list all of the possible factors of my constant term at the end and my lead coefficient. And possible factors of a negative 5 are plus or minus 5 and plus or minus 1. Possible factors of 1 are plus or minus 1. Therefore, the list of possible factors is always going to be the factors of your constant term divided by the factors of your lead coefficient. So if I take a 5 and I divide that by 1, I get 5. Excuse me, for some reason I can't write on this. 5 divided by 1 is 5, and 5 divided by negative 1 is a negative 5, and a negative 5 would still come out divided by a positive 1 is still going to be a negative 5, and if I take a negative 5 divided by a negative 1, I get a positive 5. Now I also have to do that with the plus or minus 1 over here divided by plus or minus 1 is going to give me a positive 1 and a negative 1. So my possible factors in this for this polynomial are going to be 5, negative 5, 1, and negative 1. Now how do I find out whether these are actual factors? There's two different approaches you can use. One of them is make a graph. So if you want to pause this for just a minute, take your calculator out and graph your p of x equation. And let me clean that up so you can see that a little bit better. Graph x cubed plus 2x squared plus 2x minus 5 and see where it crosses the x-axis. And those will be your factors. So go ahead, take a minute and do that. Please pause this and then return. All right, so when you graphed it, you'd see that it does cross it does cross at a positive 1. So another way to determine a factor is to take each one of these possible factors and plug it into your polynomial. So if I take p of 1 and I plug it in, I'm going to get 1 cubed plus 2 times, let me try that all over again. I'm going to get 1 cubed plus 2 times 1 squared plus 2 times 1 minus 5, which is equal to 1 plus 2 plus 2 minus 5, which is equal to 0. So if p of 1 equals 0, then x equaling 1 is a root, and x minus 1 is a factor. And you probably found that by graphing. So if I write this in factored form, I'm going to have to use my long division to do that, or polynomial division. So let's build our box. And I'm going to take x minus 1, because that's my factor, and using that Polydoku division, I want to end up with x squared plus, x cubed plus 2x squared plus 2x minus 5. So I start by putting x cubed in here, and x cubed times x squared times x gives me x cubed. X squared times a negative 1 is a negative x squared. And now 3x squared plus a negative x squared gives me 2x squared. 3x times x gives me 3x squared. 3x times a negative 1 is a negative 3x. I need 5x plus negative 3x to give me 2x. 5 times x is 5x. 5 times a negative 1 is a negative 5. Perfect. So in factored form, my x cubed plus 2x squared plus 2x minus 5 equals x minus 1 times x squared plus 3x plus 5. Hopefully remember doing some of this prior to the coronavirus situation that has come up. Please go on to the next slide. We are going to skip the problem at the bottom of this page. Now, on these next few slides, we're going to repeat what we did on that last slide. We want to find possible roots for a polynomial. So we're going to start out by listing possible factors. We're going to test those or graph to find the actual factors. And then we want to write this in completely factored form, which will require us to use polynomial division. Once we have it in completely factored form, we then want to find and determine all of the roots. So possible factors in this particular problem are going to be -4 and 4, -2 and 2, -1 and 1. So if I was to test this without graphing, I'm going to start with some of the smaller ones and work my way up. So if I plug 1 in here, I've got 1 to the 4th power plus 3 times 1 squared minus 4, which is 1 plus 3 minus 4, which is 0. Therefore, x equaling 1 is one of my roots, and x minus 1 is a factor. Now I'm going to try a -1. A -1 to the 4th power plus 3 times a -1 squared minus 4. Well, a -1 to the 4th power is 1. A -1 squared is 1 times 3 is 3 minus 4. That's also equal to 0. So therefore, x equaling -1 is a root. X plus 1 is a factor. Let's try 2. 2 to the 4th power plus 3 times 2 squared minus 4 equals, well, 2 to the 4th power is 16 plus 2 squared times 3 is 12 minus 4. That's going to come out to be 24, and therefore x does not equal 2 as a root. Now we could go through and try the rest of them. If you want to try p to the -2, or p of 4, p of a -4, none of these will equal 0. Therefore, the only two roots that we have are coming from 1 and a -1. Now we're going to use long division or polynomial division to write this polynomial in factored form. So let's start out by building our box. And I have x to the 4th plus, I like to write out all of the terms, 0x cubed plus 3x squared plus 0x minus 4, and for the one factor of x plus 1, dividing that into my polynomial of x to the 4th plus 0x cubed plus 3x squared plus 0x minus 4. Put the x to the 4th up there. This is going to be x cubed times 1 is x cubed, and I need a negative cubed plus x cubed to give me 0x cubed, and then this is going to be a negative x squared times x gives me a negative x cubed. Negative x squared times 1 is a negative x squared, and I need 4x squared added to a negative x squared to give me 3x squared. So now 4x times x is 4x squared. 4x times 1 is 4x. I need a negative 4x plus 4x to give me 0x. minus 4 times x to give me negative 4x. Negative 4 times 1 is a negative 4, and 0 plus negative 4 gives me negative 4. So I can divide x plus 1 into my polynomial. So that's going to be one of my factors. Now take your quotient, what you got when you completed that division problem, and we're going to divide the other factor into, let me switch colors. We're going to take x minus 1, and we want to divide that and get our x cubed minus x squared plus 4x minus 4. So I start by putting my x cubed up there. Here's x squared. Becomes minus x squared. And this is going to be a 0x squared plus a negative x squared gives me a negative x squared. So up here I'm going to have a 0x times x is 0x squared. 0x times 1 is a 0x. Excuse me, 0x times a negative 1 is 0x. And 4x plus 0x gives me 4x. So this is going to be 4 times negative 1 is negative 4, and I've got 0 as a remainder. Therefore, x plus 1 times x minus 1 times x squared plus 4 are your factors. What are your zeros? That's our last question. In other words, what values for x will make this equation equal to 0? Well, we already know two of the roots. X, let me change color here. X equaling a negative 1, x equaling 1, and then the last one is going to be where x squared plus 4 equals 0, which is x squared. Now solve for x. So x squared equals a negative 4. Take the square root of both sides, and you get plus or minus the square root of a negative 4. And the square root of negative numbers are the imaginary numbers. You're going to get plus or minus 2i. So our final series of solutions is x equaling a negative 1, x equaling 1, x equaling 2i, and x equaling a negative 2i. Here's a model of what you're going to be doing on the next few problems. Please take a minute to complete Part C. By finding your factors using polynomial division to write this then in factored form, and then to find the roots. Hint, you may need to use the quadratic formula to find two of the roots. When you are done, please check back for your answers. So now pause it and try it on your own. And what I did is I took the polynomial of x cubed minus 5x squared plus 23x minus 51. I plugged it into my calculator to find any real roots. And so I saw that x equaling 3 is a real root. Therefore, x minusing 3 is a factor So then using my Polydoku division, I divided x minus 3 into my polynomial, and my quotient, or the result that I got, was x squared minus 2x plus 17. Therefore, in factored form, here's my factored form. I have x minus 3 times x squared minus 2x plus 17. Now the x squared minus 2x plus 17 does not factor. So my factored form is in simplest form. I still need to find all of the roots. I know that x equaling 3 is a root, but I'm going to use the quadratic formula to find the other roots. So I'm going to take 2 plus or minus a negative 2 squared minus 4 times 1 times 17, and then the square root of all of that. Everything's over 2. Take 2 divided by 2 plus or minus the square root of a negative 64 over 2. Well, the square root of a negative 64 is 8i. So now I have 2 over 2 plus or minus 8i over 2, which simplifies into 1 plus or minus 4i. So my roots, x equals 3, x equals 1 plus 4i, and x equals 1 minus 4i. Please pause, review what we just went through. And then if you have questions, you can ask more of those questions during the office hours.